Okay, welcome students to section 3.1, radian measure. So we're going to move into chapter 3, which talks about radian measure in the unit circle. Okay, so a radian is the angle made with the radius, or when the radius is wrapped around the circle. Okay, so if R here is one radius, then the arc length when equal to that radius is called a radian. This is a radian measure. And there's about 6.28 radians in the entire circle, or 3.14 in half a circle. So we say half a circle is pi radians, 3.14. Okay, pi is about 3.14. Okay, it goes on forever. There's not really a good decimal approximation for it. It's 3.14159265 and then it just goes on forever. Okay, so it just gets more and more accurate, the number of decimal places we add, but for all intents and purposes it's about 3.14. Okay, or about 22 sevenths. Sometimes they approximate it to 22 sevenths as well. Okay, if they need a decimal approximation, then it's 3.14. If they need a fraction approximation, then we use 22 sevenths. Okay, so degrees are easier to work with, easier to use in everyday work, but radians are better for theoretical mathematics. If no unit of angle measurement is specified, then the angle is measured in radians. Okay, so how do we convert from degrees to radians? Well, we multiply by the conversion factor of pi over 180. We always want to end up with what on top with what we are going to convert to. On the bottom, we want to cancel what we're converting from. So if I do pi radians over 180 degrees, then notice that the degrees are going to cancel out here, and I'm going to be left with 108 over 180 pi radians. And sometimes these fractions will reduce. In this case, this fraction 108 over 180, if I keep chopping this thing down, I do get 3 over 5 pi, or 3 pi over 5. We could either write it as 3/5 pi or 3 pi over 5. It really doesn't matter. Okay, 3 pi over 5 radians. Okay, what about 3.257? This thing isn't going to reduce and become a nice fraction like we saw before. So I'm just going to multiply straight through 325.7 degrees times pi over 180, okay, is equal to, again, the pi radians, the radians goes on top, the degrees cancels. Okay, so again, if I were to divide 325.7 by 180, that's not going to be anything nice. So because it doesn't come out to anything nice, I'm not even going to put this in terms of pi. I'm going to multiply by the pi, and I'm going to get an approximate value in radians. Okay, so let me go to the calculator, and we're going to say, well, what was 325 point, and I believe it was 7, right? 0.7, yep, divided by 180 times, times pi. And the pi key is above is right next to the tangent. It's second, and then the caret key here, I'm going to click on it, and you'll see that it gets highlighted in red. So it's second, and then the caret key, we call that little arrow up called a caret. It's called a caret. Okay, and then 325.7 divided by 180 times pi. And I'm going to hit enter, and I get about 5.68 radians. I'm going to round to the nearest, we'll say 100th here. Okay, 5.68 radians. 5.68 radians. Okay, now we want to go backwards. What if we have radians and we want to convert to degrees? So these are radians, we call them rads. Okay, radians or RAD or RADS, however you want to abbreviate it. Okay, these are radians. So we want to go to degrees now. Well, again, whatever we want to end up with, we put on top. So we want to end up with degrees, so it's 180 over pi. Okay, I'm going to multiply this by 180 over pi. Okay, so now notice that in this case, when we have it as a nice fraction in terms of pi, the pi's are going to cancel out. I can multiply, well, the 180 and the 12, 12 goes into 180. How many times? Is it 15 times? I think it's 15 times. Let's see, 15 times 12. 15 times 12. Yeah, is 180. So that is correct. Oops, sorry about that. Okay, so so that goes in 15 times. 15 times 11, that's 165. So this is 165 degrees. Okay, 15 times 11. Okay, again, here we have a kind of a weird radian measure, negative 2.92. Negative 2.92 times 180 over pi. Again, I'm just going to plug the whole thing into the calculator, get a decimal answer, a decimal degree answer. So let's do that. So negative 2.92, okay, times 180 divided by pi, second pi. Okay, I'm getting negative 170 or 167.3. That's a negative degree. I could go with the negative degree angle if I wanted to. However, if I wanted a positive, I could just add this. I could hit the plus sign and add this to 360, and that gives me a positive now, about 192.7 degrees. So let me write that out. That was negative 167.3 degrees. If I add 360 to this, I get a positive 192.7 degrees. Okay. Okay, let's talk about some special angles here. Some special angles, okay, are these angles here. We'll go through and we'll look at the degree counterparts to these. Pi over 6, what would be pi over 6 in degrees? I'm going to multiply by 180 over pi, and the pi's cancel, and 180 divided by 6, that's 30 degrees. So that's 30 degrees. Pi over 4, okay, 45 degrees. Pi over 3, 60 degrees. Pi over 2, 90 degrees. 2 pi over 3, if I were to convert that, that's 120 degrees. Okay, 3 pi over 4, that's, well, if 1 pi over 4 was 45, then what's 3 pi over 4? Well, that's just 3 times 45. Well, that's 135. Okay, 5 pi over 6. Okay, well, if 1 pi over 6 was 30, then what's 5 times 30? Well, it's 150. Okay. Pi, what's pi? Pi is 180 degrees. 7 pi over 6. Okay, that's going to be another 30 degrees from 180. So this was our reference angle here was pi over 6 or 30 degrees. Okay, that's the same reference angle. So that's going to be 30 plus, that's 210. Okay, 5 pi over 4, 5 times 45 is 225. 4 pi over 3, that's, well, what was 1 pi over 3? 60. 60 times 4, that's 240. So you see I'm making use of these reference angles from quadrant 1. Okay, 3 pi over 2, that's 270 degrees. I already kind of know what that one is. 270. 5 pi over 3, that's going to be 5 times 1 pi over 3. So 5 pi over 3s is going to be 300 degrees. 60 times 5 is 300 degrees. 7 pi over 4, that's going to be 7 times 45. 7 times 45 is 315. Okay, and then 11 pi over 6. So 1 pi over 6 is 30. 11 times 30 is 330. Okay, and then we're back at 0, which is also, you can say that's 0 pi. Okay, it's also 360 degrees, which is 2 pi. You could say 0 pi or 2 pi, okay, which is 360 degrees. Okay, let's use this to find each function value. Okay, the cosine of 5 pi over 6. Okay, so what was 5 pi over 6? It was 150. So the cosine of 150 degrees. Let me think back to where that was located. Okay, that's going to be the second quadrant. Okay, second quadrant here. My reference angle is 30 degrees. My reference angle there is 30 degrees. The cosines are the x values. So, okay, maybe, parenthetical. If we look at the 30 degrees, the cosine, which is the x value, remember what were the x and y on for 30? The x was radical 3 over 2 and 1/2, right? Okay, so over here, since we're in the second quadrant, okay, this is going to be x. X is the x and y, right? So the cosine is the x value. Cosine is x, or cosine theta, I should say, is the x value. Not 0, cosine theta and sine theta. Okay, cosine theta is the x value, and the sine theta is the y value. So at x and y for 150, it would be negative radical 3 over 2, because when we're in the second quadrant where x's are negative, y would stay the same. That would still be 1/2. Okay, so that's where that point was located. And so what's the x value here? Well, the x value is radical 3 over 2. So the cosine of 150 degrees is radical 3 over 2. Now, is negative radical 3 over 2. And negative radical 3 over 2, okay, is approximately negative 0.866 on the calculator. And so if we plug in cosine in 150, we should get out negative 0.866. So let's see if we do. So the cosine, of 150 degrees is, yeah, negative 0.866. Perfect. Okay. Okay, what about the cotangent of 3 pi over 4? Well, where's 3 pi over 4 located? 3 pi over 4 is located in the second quadrant. Okay, and the reference angle here is a 45-degree angle. It's pi over 4. Whatever the denominator is really the reference angle. If you have 3 pi over 4 and you have a denominator of 4, then your reference angle is just pi over 4. It's just whatever that denominator is. So the reference angle is pi over 4. Well, what do we know about the tangents or cotangents of 45 degrees? Well, they are 1, okay, because at a 45-degree angle, we get a right isosceles triangle, and the cotangents and tangents are 1. However, this is in the second quadrant. Okay, remember cotangent. Okay, well, tangent is sine over cosine, or x over y. Sorry, or y over x. I should probably say tangent of theta is equal to y over x, but cotangent of theta is equal to x over y. Okay, and so since the x values are negative, okay, in this quadrant, this is going to be negative x over y, but the tangent of 45 degrees is 1. So the cotangent and the cotangent of 45 degrees is also 1. So the reference angle, the cotangent of pi over 4, is equal to 1. But because the x's are negative in the second quadrant, the cotangent of 3 pi over 4 is negative 1. So hopefully I explained that correctly. Okay, it's a lot to take in. Okay, what about this guy B, the secant of negative 5 pi over 3? Okay, so negative, I don't like that. How can I get a positive value here? Well, I do know that 360 degrees is equal to 2 pi, which in this case is equal to 6 pi over 3. If I get a common denominator of 3, then this is 6 pi over 3. Well, if I add 6 pi over 3 and negative 5 pi over 3, I just get the secant of pi over 3. And pi over 3 was 60 degrees. Oh, okay. So going negative 5 pi over 3 is the same as going positive 1 pi over 3. Okay. And where was pi over 3 located, or where was 60 degrees located? On this unit circle, this is located at 1/2 comma radical 3 over 2. Okay, so I want to take the secant, which is the 1 over the cosine of pi over 3. Then again, the cosine is the x value. The x value is 1/2. Okay, so this is 1 over x. Okay, this is 1 over x. Okay, which is equal to 1 over 1/2. And when I divide by a fraction, I multiply by the reciprocal, and so this just becomes 1 times 1/2, or sorry, 1 times 2 over 1, which is just 2. So the whole answer ends up being 2. So if we did the secant of this, we could get 2. Now, we can use radian measure on our calculator. We just have to be very careful that we know what mode the calculator is in. If I wanted to plug this secant in and check it into the calculator, I would have to just change the mode. Okay, change whether it's in degree mode or radian mode. Okay, so if I wanted to change the mode, I go to second mode, or sorry, just mode, not second, I'm sorry. So second, and then we're going to arrow down where it says radian. We're going to change it back to radian measure. Okay, be very careful, because again, we don't know if it's in radian or degree when we go to do a problem. It could be in degree mode, and we just, and it's spitting out degrees, and we don't want degrees, or it's spitting out radians, and we don't want radians. So just be very careful to keep track of whether your calculator is in radian mode or degree mode. So I'm going to hit enter. That's going to put me into radian mode. I'm going to quit out of that. And I'm going to say, okay, well, I want 1 over the cosine of, and I believe it was negative 5 pi over 3. So this is negative 5 pi. I don't need them to multiply. The calculator is smart enough to know that if I have a number in front of a variable or in front of a constant here, that you're just going to end up multiplying those together. So I don't need to put the multiplication. Divided by 3, close my parentheses, and I do get that positive 2. So it does work. Hallelujah. Okay, so that's 3.2. or sorry, 3.1. I'll see you in the next video, 3.2. Okay.